Next, we want to get the count of each letter. So this count, we use this count method, and this is a built-in method in Python, the count method, and it can be used like here. As you can see here, we have a list of 1 2 3 4 4. We want to count how many fours here. If we put another 4 like this, we have we want to count the number 4 in this list. We run this and it gives us 5. So we have 5 fours in this list. Same thing applies here. So we use the dot count method. We want to count T in this string. So thiamine nucleotide, and we get here we have 12 thiamine. We want to if we want to count A's, we get 14 G, and we get 18 G, and C we get 10. So here we count how many nucleotides of that type appear in our sequence, and this in some cases this is very important to count if we want to calculate the GC content of our gene. For example, here this actually we have stored this sequence here in a variable called mySeq, and we can use this directly instead of using this way, just putting the sequence itself dot count. We can put the variable which stores this sequence, mySequence dot count G. I want to count the G here in the sequence, and it gives us 18, just like we have done here. There is another way, another function or method in the Biopython module which does counting of the GC content, is called GC. That conveniently allows us to count the GC content of our gene just directly by running this cell. So we use it in this way: GC open brackets mySeq. So just we pass mySeq, or the variable which stores our sequence, as an argument for the GC method, and we just run this. We get 51.85. This is the GC content of this sequence which we have here. We could also do it this way. We can just put the sequence itself inside, pass it as an argument to the GC method, or use this variable like we have done now. Next, we can reverse the sequence. Sometimes we want to reverse our sequence for some reason. For example, if we have a primer sequence, we need to find the reverse complement of our primer sequence. We can do it conveniently here. First, we have this example. We have a simple list like A is equal to 1 2 3 4. This is a simple list. If we want to reverse or get the inverse of the sequence we just run this line of code: A and square brackets colon colon -1. This will reverse the sequence, as we can see here. If we run this cell, we get 4 3 2 1. This is the reverse of this list. The same applies to our sequence. If we want to reverse our sequence, we do the same. trick running this. As you can see here, we have printed the original sequence, and this is the reverse. We can also type print here in order to show in a plain text. You can see here, this is the result. This is the original sequence which we have, and this is the reverse of our sequence. Another thing, as we have seen above here, we have this sequence object. First, we have defined MySeq as a sequence object. Basically, we can change this if we want to convert it into a pure string, Python string. We can just use this method, str. Basically, str method is used on some other data types to change them into string. For example, if we have here, if we have str and we put 1 2 3, for example, and we get run, we convert 1 2 3. This is 123. We converted it into 1 2 3 string like this. So same thing here, we convert the sequence object into a string, into pure string, Python string. You see here, we run this line of code, str MySeq, and we get this pure Python string. Then we can apply whatever string methods that are present in Python. In some cases, we need the sequence in this way, especially if we want to store our string or our sequences in data frames or numpy arrays, something like that. It's better to use it in this format, a pure string, not like the sequence object as we see here. Next, we can convert our sequence or store it in FASTA format. Like here, we assign a variable called FASTA format string. What we are doing here actually is just using the Python text formatting method. Here we use this greater than sign at the beginning of the name, and then followed by the name. This is the common, the conventional FASTA format. This name of the sequence, and then followed by /n, which indicates a new line. So the first line will only contain the name, then followed by \n, then it goes to a new line, then followed by the sequence itself. Here we use the %s, and this will be replaced by whatever we put here after the %sign. So we in this for string formatting, we use the %s, and then we outside the quotes we use the %sign. Whatever we put after the %sign will be replacing this %s here. Then followed by \n, another new line. So if we run this, then we see what will be the output here. This is the output. We can print it to see it in a plain format. As you can see, when you print this kind of formatting, \n will disappear, and it will give you the how you can see it when it is stored in a text file or a FASTA file. As you can see here, the name is on the first line, then followed by the sequence, then followed by a new line, then so on. There is another way of converting a sequence into FASTA format, and we will see this later in this course in Biopython module. Next, if we have a list of sequences, okay, this is a list of sequences. It's composed of 3 sequence objects. Each sequence object has just 3 letters. So we want to join these or concatenate these 3 sequences together. So this is done easily in Python by using this code. First, we assign this variable concatenated, and we assign it to an empty sequence object. Then we use a for loop for s in list of sequences. So this for loop will iterate over each of these items here, and it will add them into this variable inside this empty sequence. So concatenated plus is equal to s. So each s of these, each one of these items will be added to this concatenated variable, which we see here inside this sequence variable. So first we run this cell, then we run this, then we see the result. Concatenated will have this form. So this empty sequence now is converted into the concatenated version of these 3 sequences inside this list of sequence, and this can be very helpful in some cases if you want to concatenate different types of sequences together. Sometimes we want to add some spacer in between the sequences we concatenate, like this. Suppose we want to concatenate these 3 sequences here, but adding this spacer here, which is formed of 10 n letters, like this. How can we do this? So first we assign this variable, which is called contigs, which is also a list of 3 sequences, just like this list which we used above. This list of 3 sequences, also we know that these are sequence objects. First we run this cell, we assign this list variable, and then we declare our spacer. What is the spacer? This 10 n letters, and we declare it in this way. Also, it's sequence object composed of 1 n multiplied by 10. This is a simple way of repeating values inside a variable like this. So if we want to make a sequence object of 10 n's, and instead of writing 10 n's like this, we just write 1 n and multiply it by 10. Suppose we want to make it 100 or 1000, that will be very difficult to count. So it's very handy to multiply it just by the number that we want. In this case, we just declare the spacer, which is here, and we run this cell. We get here a sequence object composed of 10 n letters. Then we just use the join method in Python. The join method actually takes an argument here, which is the spacer, and uses takes this argument here, the variable or the list of sequences which we have, and then adds this spacer in between each of these. So it will add this spacer here and here. So we just run, then we see what we have here. Whatever spacer we add here will be inserted in between each of these sequences. Suppose we, for example, we have another sequence here that's just random characters. We want to add the plus sign as a spacer in between each of these random characters. We run this, and you can see here we got it. The plus sign is added in between each of the characters. We have another example. If we want to add space, white space, same thing. It adds a white space in between each of the characters of the sequence. The gene sequence which we have, we run, and we get a white space in between each of the gene nucleotides, and this can be very helpful in some cases if we process these sequences for applications like machine learning or deep learning, and we will see this later. So we have come to the end of our tutorial. I hope this has been a helpful tutorial for you as the beginning of the series. You can find these good snippets in the link below for the tutorial of Biopython library on their website. Thank you for watching. See you next video. Bye bye.